So in this video, we're going to see a question from exercise 12.2, which belongs to chapter number 12, Heron's formula. So here we have a question number 3 with a big image. Let's read what the question says. It's question number 3. So let's see what the question says. Radha made a picture of an aeroplane with colored paper as shown in figure 12.15. So this is my figure 12.15. This is the aeroplane that has been made by Radha using a colored brown paper. Now find the total area of the paper used. So you have to find the total area of the paper used. So let's zoom in into this diagram of aeroplane that has been made. So as you can see, this aeroplane consists of multiple different geometrical figures. For example, you have a triangle here, okay? You have this triangle here, you have this triangle here. Then this middle part is a rectangle, as you can see, and then this part is a trapezium, okay? In fact, if we see this, every geometrical figure has been already named. So this is 1, okay? Then this is 2, which is a rectangle. Then 3 is trapezium, 4 is a triangle, and 5 is also triangle. So there are total 5 different parts of the aeroplane, and each of these parts is a geometrical figure, either a triangle or a rectangle or a trapezium. Now, our task is to find the total area taken by this paper. So, how are we going to find the total area of the aeroplane? We are simply going to add the area of each of these individual parts. Okay, 1, 2, 3, 4, 5. If you add the areas of each of these geometrical figures, then we'll get the total area of the aeroplane. Now, we are going to start from the easy and the most obvious geometrical figure and then proceed step by step. So, the first one we are going to focus on is this rectangle, quite a simple geometrical figure. Area is length into breadth. Okay, so number 2. So, I'm just going to use, okay. So, rectangle we can very easily find out. Okay, so first of all, I'm going to say 2. Okay, 2 is a rectangle. That is a very obvious thing. Part 2 is a rectangle. So area, what is the area of the rectangle? It's length into breadth. Okay, so what is the length here? So this is the length. Length is 6.5 centimeter and breadth is 1 centimeter. So quite simple again, 6.5 into 1, which is nothing but 6.5 itself. So it's going to be 6.5 centimeter square. So this becomes our area of the second part, which is a rectangle. Okay, so now once that is done, I'm just going to erase this. Okay, so okay, 2 is done, so that's clear. Now let's focus on this triangle, which is 5, and this triangle, which is 4. Now both these triangles 4 and 5 are identical to each other. Okay, so all we need to do is find the area of this triangle and then just multiply it by 2, because this area and this area are going to be exactly the same. That is the reason they have not given dimensions of this triangle, because this triangle is going to be symmetrical or identical to this triangle. Since it's an aeroplane, so obviously this left hand side triangle is going to be equal to this, this right hand side triangle is going to be equal to this left hand side triangle. Okay, so let's focus on this figure 5. Let's come to this side. Okay, so as you can see in this figure, this is a right angle triangle. Okay, so this angle is a 90-degree right angle triangle, which means if this is the base of our triangle, then this will be the height of a triangle. Okay, so if you have the height of a triangle and if you have the base of a triangle, then we can easily calculate the area of the triangle, which is given by, so once again I'm just going to, okay, so figure 5, so this figure 5 is a triangle. Okay, in fact, to be more specific, it's a right angle triangle, so I'm going to mention that right angled triangle. Okay, so area of this triangle is going to be half into base, okay, into height. This is the standard formula of the area of a triangle. There are cases when the height is not known to us, and that is when we will use the Heron's formula. However, if height is known to us and if the base is known to us, then there is no need to go for Heron's formula, which is quite complicated and time consuming. You just focus on the simple formula to calculate the area, which is half into base into height. So let's go ahead. That is equal to half into base is 1.5 and height is 6. Okay, that is equal to 1.5 into 3, which will be equal to 4.5 centimeters square. So this becomes the area of second part, this fifth part, which is 4.5 centimeters square. Now since this triangle, okay, since this right hand side triangle and the left hand side triangle are equal to each other in terms of their measurements of sides and even their angles. So this triangle's area will be equal to this triangle's area. So I'm just going to blindly, kind of copy paste and just going to say here that area of 4, this part number 4, is also equal to 4.5 centimeters square. So this is also done. This is also 4.5 centimeters square. So now let's zoom out a bit and try to see what all we have got. So this was our original figure of aeroplane, and okay, let me remove this. So this is done. This is done. Okay, so 2 is done, it is 6.5 centimeters square. Then 5 is done, it is 4.5 centimeters square, and 4 is also done, fourth part, which is 4.5 centimeters square. Now remains part number 1 and part number 2. So let's focus on part number 1 first. So if you look at this part number 1, we have this triangle here. Okay, in fact, okay, let's come down here because we have a copy of this figure so that we have a lot of space. Okay, let's get rid of this. It's the same picture. Now if now our focus is on this, okay, or let me in fact highlight this whole triangle. Our focus is on this triangle which is at the top of this aeroplane. Okay, it's in fact called as the nose of the aeroplane. So now if you look at this triangle, it's an isosceles triangle because it has to be a symmetrical aeroplane. So this side is going to be equal to this side. So since this side is 5 centimeter, this side should also be 5 centimeter. So I'm going to note that down. This is 5 centimeter. Now this side of the triangle, since this is a rectangle, okay, you know that part number 2 is a rectangle. So this side, which is breadth, is going to be equal to this side. Okay, so this is 6.5, this is also 6.5, and this is 1, and this will also be 1. So I'm going to erase this now. So if I try to zoom in a bit, this is going to be 1 centimeter. Okay, so now in this triangle, if you focus on this triangle, we have this side as 5 centimeter, this side as 5 centimeter, and this side as 1 centimeter. If we know the 3 sides of a triangle, we can easily find this area using Heron's formula. So for this part number 1, okay, for this part number 1, we have to use the Heron's formula. So let's go ahead and use Heron's formula to calculate this. So okay, first of all, we are going to say this part number 1, very important, is an isosceles triangle. Okay, this is an important observation. It's an isosceles triangle, and that is the reason we can say this side is also 5 centimeter because this side was given as a 5 centimeter. Now we all know how to use Heron's formula, so let's start it. So using Heron's formula, so first of all, we have to calculate the value of S. S is equal to A plus B plus C the whole divided by 2, and that is equal to A, B, C are the 3 sides of a triangle. So that is equal to 5 plus 5 plus 1 the whole divided by 2. That is going to be 11 the whole divided by 2. That is going to be 5.5. So the value of S is equal to 5.5. Now what is the actual Heron's formula to calculate the area? Area is equal to square root of S into S minus A, S minus B, and S minus C. This is the actual Heron's formula. In fact, let me try to change the color here so that it's a bit. Oh, what happened? Okay. Oh, got it. Okay. Color, and let's make it blue. Okay. So area is equal to this thing. This is our standard. This is our standard Heron's formula. Okay, I think the color is not changing. Fine. So that is equal to under root of S is this 5.5. So let's just continue. 5.5 into 5.5 minus A, which was 5, and 5.5 minus B, which was also 5, and then 5.5 minus 1. Okay, and the square root of this whole thing. So that is equal to square root of 5.5 into 0.5 into 0.5 into 5.5 minus 1 is 4.5. So this will be 4.5 and the square root of this whole thing. Now we know that this 2.5 0.5 into 0.5 into 0.5, square root of that is going to be just 0.5. So this is safe term. We'll just split up the square root thing. So now we are short of space. So this will be 0.5 into 0.5. This is one term multiplied by square root of 5.5 into 4.5. Okay. Now, okay, since we are short of space, okay. So basically, let's try to zoom in a bit and then I'll, okay. So this, okay. So this term, this equals to, okay, this will be equal to 0.5. So I'm just going to write here 0.5, 0.5 into, now this thing actually equals to 5, okay, square root of that equals to 5. So 5.5 into 4.5 is 24.9, which is almost equal to 25. So square root of 25 will be equal to 5. So we are going to just take it as 5, okay, and that is equal to, what is 0.5 into 5? That is equal to 2.5 centimeters square. Okay, so the area of this triangle, the nose, let's zoom out now. Yes, we started with this triangle, this part number 1, which was an isosceles triangle. So area of this triangle is equal to 2.5 centimeter square. So this is also done. Let me go to this original figure and just make a note here that area of this is 2.5 centimeter square. So I'm just going to do like this. Area of part number 1 is equal to 2.5 centimeters square. So let's box it. So this is also done. Now all our parts are done except this third one. Okay, 1 is done, 2 is done, 3 is remaining, 4 and 5 is also done. Now let's come to this part number 3, which is actually a trapezium. So let us, I think we don't have too much space here, so let's use this space only. Okay, so I'm going to redraw this trapezium so that it's a bit better to understand. Yes, so this is how our trapezium looks. Okay, and line here and line here. Okay, and what are the dimensions? Let's write down the dimensions. This is 1 centimeter, this is 2 centimeter, this is also 1 centimeter, and this is also 1 centimeter. Okay, so this is our trapezium with all the dimensions. Now how do we find the area of a trapezium? So the area of trapezium is given by, in fact I should have, fine. So yes, so the area of trapezium, let's use the blue color. Okay, so area of trapezium, area of trapezium is equal to a plus b, okay, the whole divided by 2 into h. Okay, so what is a and b? So a and b are the parallel opposite sides of a trapezium. We know that trapezium, the characteristic feature of trapezium, a quadrilateral, is that two opposite sides are parallel to each other. Okay, so let's call them a and b. So in area we need these values of a and b, which are the parallel sides of a trapezium, and we need the value of h, which is the height of a trapezium. So this is going to be the height of a trapezium. This is going to be the height of a trapezium. So let me draw this. This is also going to be a height of a trapezium. Now if this is 1 centimeter, then this portion will also be 1 centimeter. Let me use a highlighter here. Okay, if this is 1 centimeter, then this is also going to be 1 centimeter. So I'm going to use a different color to mark that. So this will be also 1 centimeter. So, and this whole is 2 centimeter, which means this has to be 0.5 and this also has to be 0.5. So I'm just going to write here, this is going to be 0.5 centimeters and this is also going to be 0.5 centimeter. Okay, so let's use a highlighter once again. So this is 0.5 and this is also 0.5. Let's try to zoom in. Okay, once again I'll quickly revise what we have done. So we have constructed a perpendicular line from this part to this part. So obviously this becomes a rectangle. Okay, so if this is 1 centimeter, then this portion in green will also be 1 centimeter. However, the length of this hole is 2 centimeter. So out of which 1 centimeter is gone and only 1 is remaining. Now we have to divide 1 into 2 equal parts so that this will be 0.5 centimeter and this also will be 0.5 centimeter. So this is how this whole 2 centimeter comes into play. 0.5 plus 1 plus 0.5, which is equal to 2 centimeter. Now, our function or sorry, our purpose is to find the height of this triangle. Okay, if you find this height, which is basically the height of a trapezium as well, then we can easily use this formula to calculate the area of the trapezium. So again, this triangle, okay, is a right angle triangle, is also equal to this triangle. Both the triangles are same, so any of them will do. We'll try to focus on this side of the triangle because I have an empty space here. So once again, this is let's use, okay. So once again, this is a right angle triangle. Okay, so we have this hypotenuse, we have this one side, and we have to calculate the other side. So what I'm going to do is, okay, let's name it. So this, let's call it A, B, and C, and then I'm just going to say, yes, in right angled triangle, right angled triangle ABC, okay, we will say AB square is equal to BC square plus AC square. Okay, why can we say this? Why are we saying this? Because it's basically a Pythagoras theorem. So let's make a note of that. This is from Pythagoras theorem. Okay, so let's substitute the values now. Okay, sorry. So yeah, what is AB? AB is 1, so it's going to be 1 square is equal to BC is 0.5 square, so it's going to be 0.5. That is going to plus AC square. Okay, so that is 1 square is 1, that is equal to 0.5 square is 0.25. Okay, plus AC square, and therefore we are going to get 0.75 is equal to AC square. Okay, and therefore AC is nothing but is going to be under root of 0.75. Now what is the value of under root of 0.75? So it is equal to 0.86. Okay, so it's almost equal to 0.9 because 0.9 into 0.9 will be 0.81 because 9 square is 81. So it's very close to that, 0.86 centimeter. Okay, so that's it. We have got the value of AC. So I'm going to take this value of AC and just take this value of AC and substitute here in this figure. So which is equal to 0.86. Let's zoom in here. Okay, so we have this as 0.86 centimeter, which becomes the height of a trapezium. Okay, so that will be H. So let me make a mark it. So this is H. Okay, so this is A, this is B, and this is H. I know there's a lot of mess here that has happened, but focus on this A, B, and H. So now let's come to this part. Yes, so let's continue here. Area of trapezium, and now that is equal to what is A plus B. So that is 1 plus 2 the whole divided by 2. Okay, once again, just to focus, I'm going to use this. This is A, okay, 1 centimeter. This is B, that is 2 centimeter, and then this is 0.86, which is the height. So let's substitute that into 0.86. Okay, so now that is equal to 3 by 2 into 0.86. Okay, and that is equal to 3 into 0.43. Okay, that is equal to 3 3 is a 9, 4 3 is a 12, and 1.29 centimeter square. The area of trapezium comes out to be 1.29 centimeter square. So now let's come here and let's make a note of this, that this area, oh sorry, let's use a black color. So this first of all, this part number 3 was a trapezium. So let's make a note of that. It was a trapezium with the area, what was the area? 1.29. So 1.29 centimeters square was the area of the trapezium. Okay, so now what we should do is we should move this down so that I don't want the mess here. Okay, instead of doing that, let me just cover this so that we can focus on things that we want to focus on. Okay, so this is our rectangle that we started with, and we now finally have, let's erase this, we now finally have all the, yes, we now finally have all the areas of all the 5 different parts of the aeroplane. So this is part number 1, sorry, 2.5. This is part number 2, which is 6.5. Part number 3 is 1.29, and 4 is 4.5, and 5 is also 4.5. All we have to do now is a simple addition. So I'm going to move a bit down and I'm going to write here total area. Total area is equal to, so 2.5, okay, plus, so let's go part by part. Part number 1 is 2.5, part number 2 is 6.5, so that is 6.5 plus, then part number 3 is 1.29, so 1.29 plus, and part number 4 is 4.5, 5 is also same 4.5, so that's just going to be 4.5 plus 4.5. Okay, this is the total area, and yes, so that is going to be equal to 4.5 plus 4.5 is going to be 9, plus 2.5 plus 6.5 is going to be again 9, plus this 1.29 as it is in the middle, then 9 plus 9 is going to be 18, plus 1.29, so it's finally going to be equal to 19.29 centimeters square is the total area, or the total yes, the total area of the brown color paper. Okay, the paper that was used, sorry, color, any color paper that was used by Radha to make this aeroplane. So in this way we have solved this problem completely. It's a little lengthy problem, not really complex. It's not a really difficult or a complicated problem. The thing is, it's lengthy, so we have to go step by step, be calm and focus on each and every portion of this geometrical figure that was given to us. The only place where we had to use Heron's formula, where there was absolutely no other option, was this figure. Okay, figure number 1 or part number 1. Here we had to use the Heron's formula. These two triangles we used a simple formula, half into base into height. This was a rectangle, and then at the trapezium also we had the trapezium formula to find its area. So this was the only portion where actual Heron's formula was used. So in this way, problem number 3, this problem number 3 from exercise 12.2 is done.